So how do we decide where this inequality or this polynomial is above the x-axis is basically what it's asking us, because it's asking us where is it greater than 0. So I know it's equal to 0. I mean, if we pretend this is an equation, right? We've got it in factored form. And we know where is it equal to 0? Well, I know it's equal to 0 when x equals 3, and I also know it's equal to 0 when x equals 6, because those are the two roots, right, if we think about it that way. So when I'm trying, now that they're making this an inequality, well, we've got to decide what's happening either side of these zeros, because I know that the function is equal to 0 at those two, right? So we got to decide what's happening either side of it. So one of the easy ways to do this is to make yourself a number line, and then substitute in values, or think about what values. You don't actually have to do the substitution. You just want to think about the sign of the value. So I'm looking at the 6 minus x squared. Well, it doesn't matter what we substitute in for x in that problem. It'll always be positive because we're squaring it. Okay, now this one's going to be the critical thing. So the critical value. So if I substitute in a number to the left of or less than 3, like say negative 10 or negative 1 or even 0, this is going to give me a negative number times a positive number. So a negative number times a positive number, because we know that this term will always be positive because of the square. Well, a negative times a positive is a negative. So that tells me this whole function is going to be less than 0 on that interval. I come back into this next range between 3 and 6. Well, if I substitute in a number that's greater than 3 into the x minus 3, that'll be a positive number. And the same thing with that'll be positive. So I've got a positive times a positive, so that'll be positive. So that's certainly in the interval, or works. That interval works. And then when I'm greater than 6, the same deal. This, if I substitute in 6 minus, or not 6, but if I 7 minus 3 or 10 or whatever, that'll be a positive number, and the other terms are always a positive, so that's positive also. So I'm seeing two intervals where it's greater than 0. So I mean, certainly I've got the x is greater than 6 checked. That takes care of that part. And I guess I got to go in between 3 and 6 for the other part. Now, why can't we just check the x is greater than 3? Well, the problem with that part is, even though these are all positive here, right there the function is equal to 0, so it's not greater than 0, so it doesn't include 6. So using interval or inequality notation, we need to break this up to the two parts. Okay, so those are the two intervals that are included in the solution of this inequality. Approaches from a graphical standpoint also. So I graph that function and I found the zeros, and I'm looking for, because this inequality was asking me, when is it greater than 0? When is it above the x-axis, basically. So there's that interval. That graph is above the x-axis, and so isn't it there, where this is less than. If you think about that sign chart I did, that's what we showed. When it was less than 3, it was negative. The y's were negative. Between 3 and 6, it was positive. Then it's back down to 0 for a minute, and then it's positive or above the x-axis when x is bigger than 6, right? So when x is bigger than 6, y is positive. All right, so that's another approach. I mean, and it's good to be able to do it both ways, analytically and graphically. Okay, hope that helps.